okay? So just in case you've forgotten from last week here, okay? Your inclined plane, the forces go like this, right? Gravity is the vertical force. This is normal force, which we'll very rarely, if ever, use, okay? And then the vector sum of those two forces is what we call the downhill component of gravity, or F parallel, okay? It's how fast or how hard it's being pulled down the hill by gravity and normal force acting against each other. All right, so that's what we talked about before. This is theta, and so is that. Okay, we talked about that on Friday. Okay, so just kind of quick review of that concept. And so for this question, obviously this would be 50 kilograms. You can put on the other forces that are involved and kind of work your way through it. Okay, and then we'll go through it together. All right, so for an inclined plane, gravity tries to pull the box straight down. Obviously, because it's sitting on a solid surface, the ramp, there's a reactive force from the ramp. In the same way there is when I'm standing on the floor is pushing back on me. Okay? Any solid surface pushes back, but it always pushes perpendicular to itself. So that means that normal force, the reactive force, and gravity are offset by the angle of the incline. That's why this angle and this angle are the same number. Right? Now, because I know the mass of the child, can I calculate their weight? Okay, so Fg will very simply be m times g, so 50 times 9.81 is going to be 490.5 newtons. All right, so I know that this side here is 490.5 newtons. Now that I know the hypotenuse of this triangle, I can calculate the opposite side, which we said was F parallel. So that's simply going to be trig, right? And in this case, it's a 25-degree incline, so the sine of 25 times 490.5. Sorry, I forgot to fire up my calculator, I guess. By the time I get to 207.29. Newtons. Okay, so this force here is 207.29 newtons. All right. The other thing they tell me is that friction resists with a force of 150 newtons. Which way should I draw friction?
Down or no, back?
Back, yeah. Right. Friction always resists. I mean, it says resists in there. If the child is sliding down the ramp, friction has to act up the ramp. Okay, friction is always going to oppose. So I would draw friction this way, and I just go FF and go 150 newtons. Okay, I think I've got all the forces that matter. Okay, I mean, I didn't calculate normal force, but I don't need it. Okay, so I've got F parallel, I got the force down the ramp, I got friction, the force up the ramp. There aren't any other forces there. It doesn't say anything about anything else here. Right, so all I have to do then is calculate the vector sum of all forces. So that'll be F parallel plus the force of friction. So I'm going to say 207.29 plus negative 150. You could just subtract 150, it's fine. Okay, that'll give me F net. So, sorry, I'm just going to get that full number in here. Sine 25 times. Wrong number. 490.5. There we go. Oh, decimal sign. Nice. Sine 25 times 490.5. Okay. Oh, just do what I want. Okay, so there's my number 207. I'm going to subtract from that the force of friction, which was 150. Okay, so there's my net force, 57.29 newtons down the ramp. Okay, question wants to know the acceleration of the child. That's where I go back to this. We talked about this last week a ton of times. Every question is going to require you to do vector sum of all forces and then m times a, or m times a and then vector sum of all forces. They're always going to be part of every question. All right, so acceleration then will be f net divided by m, so that'll be 57.29, okay, divided by the mass of the child, which was 50 kilograms. Okay, so to two significant digits, 1.1 meters per second squared down the hill. Okay, is that ringing a bell? All right, now, eventually, we'll combine those system questions that we learned about last week with the pulleys and everything with inclined planes, and you'll get something like this. Now, when you first look at that, it's like, oh my God, I quit. Okay, which is not, of course, how we want to approach a problem. But when it comes right down to it, what's acting on the 10 kilogram mass? Gravity. So that would be a downward force. Okay, this would have gravity acting on it as well. That would be an upward force. Okay, would there still be gravity and F parallel and all of that acting on this? As long as you can figure out what forces are involved, it's just a matter of calculating them. Okay, when this one comes right down to it, on that 5 kilogram box, okay, there's this force here, the gravity from the 10. Okay, this force here, that's the gravity from the 8. And F parallel on the 5 kilogram box. It doesn't mention any friction. There's really 3 forces here. Now there's one other trick. What do we have to remember about systems?
It applies to the whole system.
Right. So when I'm finding the acceleration here, I'm actually dividing by how many kilograms? 23. Yeah? Okay. That would be, you know, honestly, if I put this on a test, pretty much everybody would get that far, and then they'd forget that whole divide by the whole mass thing, because I would totally word it as what's the acceleration of the 5 kilogram mass, and a lot of people would divide by 5, because just looking at this would throw them. Okay? They'd eventually get to that final point and then make that little silly mistake. Okay? It's maybe like I've done that before. Okay. So on that worksheet there, guys, that I just gave you, there's a few questions I want to try here to start off with. Okay, sorry, I'm going to open it up. Yeah, do it this way. Okay, so on that first page, Newton's second law worksheet there, okay, I would like you to circle number 5. Okay, so let's say 5. Eight. 11. 13. 15. And 19. Okay, let's do those ones for now. Okay, so we'll start out with those 6. We'll see what we're at for time. And then we'll go through each one. Here, I'll give you a few minutes, and we'll go through number 5. A few more minutes, we'll go through number 8. If you're having trouble, just let me know, and I'll come around and help you. Okay, so number 5 is the kind of question that actually brings in a little bit of stuff from kinematics, and you will see some overlap there. Okay, we know the mass. Okay, it's 925 kilograms, so we certainly could draw a free body diagram here. So 925 kilograms, and it accelerates from rest. So VI is 0. Okay, to 25 meters per second. okay, in 10 seconds. All right, what is the force acting on the car during this time? All right, so we would have to say net, well, it does say net force. So we're just looking for, all right, what is this force? It's not asking us to calculate any other forces, just the net force. So all I have to do is calculate the acceleration first, okay? The vector sum of all forces part of this is, I don't know any of the forces and it doesn't ask, so it doesn't matter. All right, I did the vector sum of all forces part, okay? So the acceleration will just be Vf minus Vi over t, so 25 minus 0 over 10 gives us 2.5 meters per second squared, and I'm just going to say it's positive, or sorry, self. It does say self. All right, now that I've got that, then it's just F net equals m times a. So it's not a tough question, it's just it has two parts. So 925 kilograms times 2.5, and that's going to give us 2.31 times 10 to the 3 newtons. So, okay, any questions on that one? Anybody still want time on number 8? Yeah, okay, I'll give you a little bit more time on that one. Okay, so number 8 is one of those questions I was talking about last week when we did the elevator questions, and I said this is a question where people forget what force? Gravity, yeah, because they just picture this thing being thrown up in the air, they draw a free body diagram and they just draw this, right? And this would be the applied force upwards. They forget, okay, that this is an 11 kilogram object that has weight, because, well, we're on Earth, okay? There's no up unless there's gravity to define down. Right, so we got m times g here, right, and so that'll be 11 times 9.81, should be 11.77, right, so 107.91. So 107.91 newtons, and that would be downwards. All right, so the upward force is the 145. Okay, once you realize that, this is a pretty easy question because you just have F net equals 145 minus 107.91, the two act in opposition to each other, and then you have your net force on the elevator, rock, whatever object that's being thrown up in the air. 11 kilograms is pretty heavy, right? So 145 minus the weight, and it gives us a net force of 37.09 newtons up, and then acceleration is F net over m. Okay, so that's just our 37.09 divided by 11 kilograms, which should give us 3.37 meters per second squared. Up, don't forget the up. I don't have it on my answer, which makes my answer wrong. Okay, you would need to have the up on there for sure. All right, give me a few more minutes before we go through the next one. All right, so we simply have that 20 kilogram object that's being pulled along a level floor. So 20 kilograms, okay, being pulled this way with a force of 27.0 newtons, right? And it says that it is accelerating at 0.80 meters per second squared. We're looking for how big is the force of friction. All right, what can I calculate since I know mass and acceleration?
Force net.
Right. F net is mass times acceleration, so 20 times 0.8 should give me 16 newtons to forwards, right? Okay, so now I've got my net force. Okay, now that I know that, I can do the vector sum of all forces. So F net will be the 27.0 newtons plus the force of friction. All right, bring the 27 newtons over here. I'll have F net, okay, minus 27 newtons equals the force of friction. So that'll be 16 minus 27, which will give me negative 11 newtons. Right, and that's all we can get because they don't even say forward. They just give me numbers that are that way. Okay, so all I can say is this is in the other direction, so it's negative. All right, everybody with me there? Okay, like I said, on Wednesday, we're going to do our lab, okay, but we'll continue working on Newton's second law Thursday and Friday, okay? okay? And then at that point, I'll kind of have an idea of where we're at in terms of when the unit exam for Unit 2 will be. I think we'll probably still do a little bit of Newton's second law on Monday, but we'll have to move on to Newton's third law by next Tuesday, okay, in order to kind of keep on track. Alrighty. Best bet, make sure you're working on some of the ones there from the book, okay? Do one or two at home. If you have trouble with them, come and see me, okay? But we will have a little bit of time to work on it in class. All right, we got to make our way over to the church for the Remembrance Day thing.